transformed up-down methods. So you can have a minus plus up-down. That means 50% yes or 50% no. You can have one up and two down. That means one no and two yeses. Then the probability of yes is about 70%, and you can have two up and one down. That means it's about 29.3% of yes. It's 1 minus 70. 100 minus 70% is almost 30% for yes. You can have three in a row, up and three down, one up, three down, and then the probability of down, or then that will say probability of yes is a third root of a half is about 79.4%, and so on. So we have a little bit difficulties here. Yes and no experiments criteria vary. The criteria vary. Can we avoid bias? So we have a P curve, the probability of a response, the condition that we have the signal is absent, and then another probability of a measurement, the condition that there is a signal. R is a physical or internal variable, and we have a criterion. Makes things a bit formal. From introduction to signal detection theory, we have two hypotheses. Signal is absent H0, or signal is present H1. Observation or measurement R may be a vector or a set of measurements. Based on observation R, detector selects a hypothesis. Then we can also calculate P's probability of H0 conditions R, and so on. We have a general case. So we have those two curves, P, R, conditioned, the Gauss curves, P observation condition that we have the zero hypothesis, and the other one is a probability of a measurement of signal is a condition that we have the alternative hypothesis. The signal is present. We have a detect and we have a criterion. Detector logic. If this R is less than criterion, then you can say R is to the left on the first axis of the criterion. Select H0, the zero hypothesis. That means signal is absent. If R is greater than criterion, to the right of the criterion, then select the alternative hypothesis that signal is present. Then we have four possible outcomes. We have, first of all, if signal is absent, we have the H0, and we select 0. Then we have a correct correction, or correct rejection, or true negative. So we are under this PR H0 curve with an area. But if you have signal absent and but we select that there is a signal. Signal is absent, but if we select that is a signal. Then we have the false alarm. This is a small green area on the figure. The other one, correct rejection, was the blue one under the PRH0. So if we say signal is present, H1, we have a present signal, but we select that there is no signal. Then we have a false negative. That means that we have under the PRH1 curve, because there is a signal present, but we are to the left of the criterion, and we have some this you can say yellow area on the figure. And then if there is a present signal is present and we select H1, so we got the red one. We hit. Okay. Yes. So we come later to those rock curves. If we select H1 and the signal is absent, we have false alarm. If we select H1 but the signal is absent, we have false alarm, the green area. But if we select H1 and the signal is present, we get this hit. Yeah. Consider receiver operator characteristics, ROC, receiver operator characteristic. Consider performance for criteria. We have those two curves, P probability, those two Gauss curves, you can say, has the same form anyway as a normal distribution. PR conditioned H0, PR conditioned H1, and we have physical or internal variable. So we are looking at the false, as the first axis, false alarm rate and the hit rate. False alarm hit rate is that we select H1, that there is a signal, but there is no signal. It's a false alarm. Then the hit is we select there is a signal, and the signal is present. So we have the hit. So that's about a rock curve. So if you can say if the rock curve is like the first one here, the green one in the upper is more upper than this line selection line, this dipped line. Then we have it's okay, and with the false alarm rate is higher than you can say the hit rate is more than bigger than the false alarm mostly, or the other one, the more bad situation that the false alarm rate is bigger than the hit rate. So yeah, we get two different curves, and we can change if we test the subject criterion. As the criterion is changed, the point will move to another position on the same rock curve. Yeah, and so on. We can minimize the error. We have the probability density function. Now we call it right way probability density function. And we have those two, PR conditioned H0 and PR conditioned H1. We have if the critical criterion is in the middle. Those two curves are intersecting and they are equal form, and in criterion is just in the middle. We are minimizing the error. And then we can also calculate P. We can also calculate P H0 condition R, or pH1 condition R by Bayes rule. PRH0 condition 1. What is the probability to select the zero hypothesis if there are any signal present? If there is a signal, yeah. What is and so on. Yeah. Yes. Okay. Alternative forced choice. Example of two alternative forced choice presentations. Listener must pick the interval that contains the signal first or last. Can be extended to more options: 3 AFC, 4 FC, and so on. That was it. Then there's some multi-dimensional scaling. Ask listeners to rate how different or similar each pair of stimuli are. I will not come through this. That was part 2. Thank you.